Okay, now what we're going to do, first of all, we're doing the first development 1. So this is drawing 8.1. And we're going to label our top. Now I usually label the top as 0, 1, 2, 3, 4. And I'm going to call this Z. I'm going to put a line through just so we don't get it confused with 2. A, B, C, and D. If we look at the top, we can see that points 0, 1, and 4, they're all on the same point. They're all on that dot. They're all running through that location. Here we have 2 and 3, right? They're on that, both in this point. Down here, we can see B and C are both in that same point, and A and D are here. Now, I'm a big believer that this is really valuable labeling things, so you've got a way to refer to things. You've got a terminology. Okay, the first thing we're going to do is we're going to draw this seam, right? So we're going to draw the seam, and we can see that in this view, well, I'm going to use the term, now we don't normally use top view and front view, but I'm going to use the term plan and the term elevation this time, right? And the reason I'm going to do that is just so that we can use terms that make them a little bit faster. Okay, so we've got this line here, this 0Z and 0Z. They can't be the same length, right? The plan length is like 20 millimeters. And down here, it's 45 millimeters, which is correct.
45.
45, okay. How do we know that's 45?
It's a true length.
It's a true length. How do you know it's a true length?
Because it's perpendicular to the direction.
Yeah, it's perpendicular to the viewer, right? So that when we're looking at it, we're looking at it, and this line in the elevation is not moving further. It's not going into the page or out of the page. It is the same distance away from the viewer here as here. Right, let's say if I'm standing in a fixed location, it's the same distance relative to the glass of the camera, right, in both views. Now, in this top view, 0 is a lot closer to the viewer than Z is, right? So 0 is a lot closer than Z is in that view, so therefore it's not a true length. So what I'm going to do here is I'm going to use the terminology. We're going to put a line here, and we're going to say in this, because we've got a couple of lines acting in the same pot, we're going to say ZO, right, is a true length. And here we're going to say TL, and the notation I'm going to use is I'm going to use a triangle pointing to say it's a true length down here. It is a true length here, and it's pointing down to the true length. Okay, if we look at some other sizes, we can see 0, 1. Now, is 0, 1 a true length?
Yeah.
Right? Why is it a true length?
It's perpendicular.
Okay, yes, because it's anything represented as a dot in the other view is always a true length. So 0, 1 is a true length up here, right? 0, 1 is a true length up there. So we can say that that is in fact a true length. Okay, what about ZA? True length or not a true length? I want everyone to give a thumbs up or thumbs down, yeah? So I can have a look and see, we're going to make a prediction. Okay, not you, right? So because it's a dot, because AZ is a dot, that means it's a true length. AZ is a true length in this view, right? True length. Okay, what about, it's literally A and D are both in that same spot.
No, but what do you mean by dot?
They're occupied by a single point on this piece of
Oh,
paper.
is that what you mean?
Yeah, that's what I'm talking about. They represent, by the same square of ink. Yeah. Okay. Here we've got A1 or 1A. Right? Are we calling that is that a true length or not? No. Okay. So we should be seeing thumbs down, right? Everyone should be giving me a thumbs down, so they're indicating what the length is. Now, the idea is if we look at AZ, right? 1Z. So we say 1 is at this location and Z is down here. Well, it can't be 45 millimeters the same as OZ. That doesn't make sense, right? Because it just doesn't make sense that they would be the same length. We would expect this one to be a little bit longer. So it means it's not a true length in either view, right? Now, we can calculate how that value is, but for the moment, we're just going to put a cross on it to say not a true length. We're going to calculate that later. Okay, what about 1, 2? Is that a true length?
Yeah.
Now, I don't know if this is a rule, but we can say it's 20 mil here and 20 mil here. That's a pretty good sign it's going to be true length. A better way to think about it is, though, if we look at this piece of this here, we can see that this flat surface is parallel to the camera, right, or to the glass of the camera. It's not moving, it's not sloping away. This here is sloping away. The letters are all further away from the numbers. But all of the numbers, they're all the same distance away. They're not sloping up or down in this particular drawing. If we look at other drawings, here we can see these numbers would be sloping away, right? So these ones would not be a true length in this value, but they are a true length here. So if let's go with the same notation. We're going to call this 1, 2. 1, 2 is not a true length here, but it is a true length here. 1, 2 is a true length here, right? Because in this view, it's falling away from the viewer. Here, it's not falling away from the viewer. Here, it's the same distance. The 1, 2 is not moving back or forwards away from the viewer. Okay, so 1, 2 is a true length, and it's actually a true length in both. True length here and a true length here. AB, is that a true length? Thumbs up, thumbs down. Okay, so everyone's giving me a thumbs up? Okay, great. So that's a true length. It's a true length in both views, right? In this case, it's a true length in both views. But we have other questions like this where we might not get a true length on the bottom, right? So that true length isn't a true length there. Yes, that's actually the top of the thing, but you get the idea. Okay. All of these sides, none of them are true lengths, right? Not true lengths. In this particular drawing, they're all the same. In this drawing, they're not, right? So it's easier here. We can just find the true length for all of them. They're all going to be the same because it's a symmetrical object. Now, the thing that's, okay, with that, we've got enough to get started, and we can say that 0Z is 45 millimeters, which is exactly the size they've already printed. Oh, that's very generous of them. They've already given us the same. They've told us the same as the right length. Now, in this particular drawing, we can say that we can be confident that because 0, 1 is a dot in this view, and because ZA is a dot in this view, and because it's shown as being perpendicular in this view, we can actually do a bit of a cheat, and we can just draw those lines, just draw them perpendicular to the seam, right? We don't always get this lucky. Sometimes you do, sometimes you don't. In this here, if we get the true length, will we get a true length? No. But it is perpendicular here and there, so you would. Here you do, yeah, you do there. I think with all these, but in this case, if we don't have a seam, that's often why they give us a seam, is so that we get a perpendicular starting point. If we just had to start from one of these sides, none of these are perpendicular, so you have to find that first point. But for us, we're really lucky. Okay, so we know 0, 1 is a true length, and it's 10 mil, so we can just draw it in, 10 mil, boom. Oh, we're going to label this. We're going to label this as 0 and Z, and we're going to label this as 1. And we're going to go down here. We're going to Z to A, that's 20 mil. And with that, we've got our first side. Z, A. Okay, so now what we're going to do is we're going to go from there, and we're going to find point 2. So I'm going to get my compass. If I was smarter, I would have had this set up, but not. Okay, so we know the true length of 1, 2, right? We know the true length of 1, 2, and we know that we can measure from 1, and we're going to say that the true length this line 2, point 2 has to be somewhere on this line. So if we have line 1, 2, point 2 has to be somewhere on that line. The question is where, right? The question is where. So the problem is we don't have any other, we have to find another way of finding 2. So what we're going to do is this process called triangulation. And with triangulation, what we're going to do is we're going to draw this line A2. Now A2, do you think it's a true length?
No.
It is not a true length. Okay, so we're going to do our first true lengths. Now, what we're going to do is we're going to draw a triangle that has the height of A to 2, right? We're going to find the height of A and 2, and we're going to draw that, right? So we're going to measure off the elevation, and we're going to find the distance between A and 2, right? So we're going to call that A2 elevation, and we're going to find the length in the plan view, right? Whatever we want to call this, that distance here, right? This distance here is how far away they are on the plan view. So we're going to call that A2 plan. And the hypotenuse is going to be the true length A2. Now the thing is, how are we going to do that? Well, there's a couple of ways we can do that. The easiest way is we can say, in this case, A and 2, that's the height. A and 2 would be the height. But we can see here, the A and 2 height is going to be different to the A and 1 height. Yeah? So really pay attention to that. That's not always going to be as easy as this. But in this particular case, we can just draw this and say, well, that's the elevation value, the height of A and 2, right? Rather than getting the calculator out, we are allowed to use the calculator. And in my videos, I literally just get a calculator and we calculate the true length, right? We calculate the true length. But here, we've got the height, and now what we're going to do is we're going to get the plan value, right? I don't have a good word for the plan value, right? Someone come up with a good value, but word for that, and that's going to be that. Now we've drawn it to scale, right? We've drawn the height of A2 and the width of A2, and now we can calculate the hypotenuse. Or, because we've drawn to scale, we can just take that value straight off. We can call that A2 true length, right? Just like we did there. Rather than calculating it, we can just use our compass, which is pretty fast, right? And then we've drawn that line, and we're going to say A2 is that line. We know that 2 has to exist where 1, 2 and A2 both meet. Where A2 and 1, 2 meet is going to be our point 2. Does that make sense? Okay. So we're going to draw that line in. Now, I'm going to teach you another trick. Another trick is, in this drawing, we can be pretty confident that 1, 2 and AB are parallel, right? We can look at it based on the fact that they're both perpendicular here and parallel here, right? They're probably going to be parallel. So what you can do, again, it's another cheat, is you can draw your lines parallel and say, I know that is AB, right? And I can draw AB and that's a bit of a cheat. What you're supposed to do, I'll show you how, so that gives us B straight away, right? I'll show you how you're supposed to do it. What you're supposed to do is you're supposed to say, well, I know the length of AB is somewhere on that arc, right? That's the AB arc. Okay. AB is somewhere on that arc. And then what we have to do is we have to use the true length of B2. And when we try to find the true length of B2, right? B2, the height of B2 is the same, right? We've gone from B to 2. This is the height of B to 2. That's the height, the value in plan is from B to 2. That's its height. And then this is its plan value. So we write the plan value there and we can mark that off and we can then say this is true length B2. B2 true length. Now, I said earlier, because this is symmetrical, it should be the same length as A1, which it is, right? So again, if you wanted to cheat, that's something else you could do. Now, we're going to say that measuring from 2, right, we should get a line that we say B2 is somewhere on that line. So if B2 is somewhere there and AB is somewhere there, we know where those 2 points meet is B. Now, that's typical. Then the HSA, they will very rarely ask you to draw more than that, right? They won't ask you to draw the whole thing.